In section 1.5, we will talk about linear inequalities. An inequality is a number that has the symbol greater than, less than, greater than or equal to, or less than or equal to. Let's take a look at something like x less than 4. So the solution to this inequality is any number that is less than 4, like 3 or 2 or 1 or 0 or -1 or -2, or even something like 2.5 or 2.4. So because we have an infinite number of solutions, infinite number of values that are less than 4, then we have to find another way to list all these solutions. There are two ways of listing solutions. One is using a graphical representation. You can graph an inequality on a number line, or using interval notation. Now, here are some rules for interval notation. If you have a less than or a greater than inequality, we would use parentheses. The parentheses indicates that the number is not included as part of our solution set. For example, if we have x less than 4, that means 4 is not included, but anything less than 4 is. So let's say my goal is to eat out less than 4 times a week. That means I can eat out 3 times a week, or 2 times a week, or 1 times a week, but not 4 times a week. So x has to be strictly less than 4. That is indicated using a parentheses. If you have a less than or equal to, or a greater than or equal to, that is indicated using a bracket. And if you have infinity or negative infinity, that is always using parentheses. So let's graph x less than 3. We want the set of all numbers that are less than 3. So let's take a look at 3, which is here. And by the way, a parentheses is same thing as an open circle. A bracket is same thing as a closed circle, and infinity is just infinity. So at x equal to x, for x less than 3, you can either have a parentheses or you can have an open circle. So in MyOpenMath, because they use open circles, I will use an open circle on 3. Now you want the set of numbers that are less than 3. Less than 3 is like 2, 1, 0, -1, etc., etc. Numbers are getting smaller. Anytime numbers are getting smaller, they approach negative infinity. Okay, so if you have a less than or a less than or equal to, then they're going to approach negative infinity. They're going to get smaller and smaller. Now, how do you write this in interval notation? Well, in interval notation, it's always going to be the lowest value of a solution set and the highest value of a solution set. Once you have a graph, you just look at the lowest value. In this case, the graph is going towards negative infinity, so that's going to be, it's not really a value, but it's a concept that numbers get smaller and smaller. So on the left side, we have negative infinity, and the numbers go up to 3 but don't include 3. So we're going to have 3 with a parentheses. And again, anytime you have an open circle or just a less than, it's going to be parentheses on interval notation. Next one, we have y greater than or equal to -4. So first off, because we have a greater than or equal to, this is going to be a closed circle. Greater than means numbers are getting bigger and bigger, like -3, -2, -1, any number that is greater than or equal to -4. So if you have a less than or equal to or a greater than or equal to, then instead of a parenthesis, instead of going to negative infinity, it'll go to positive infinity because numbers get bigger and bigger. Oops, sorry, I meant a greater than or equal to, the numbers approach infinity. So infinity is this way, and numbers are getting bigger, so this will be your graph. Now, the lowest value of the solution set is a -4, and there is no highest value because the numbers approach infinity, so this is your interval notation. Next one, we got x less than or equal to -2, so we have a closed circle on -2. Less than or equal to, they approach negative infinity, so they're going to get smaller and smaller, and our solution set is going to be negative infinity, comma, -2. Notice the -2 as a bracket because we have a less than or equal to in a closed circle. Lastly, we have x greater than 0, so we have an open circle. Greater than, it means we're going to the right, approaching infinity, so this is going to be 0, comma, infinity. Now, we're going to be solving linear inequalities in the next part of the lesson, and then we're going to graph it, and then we're also going to write the solution in interval notation. So solving linear inequalities is very similar to solving an equation, but there are two main differences. Number one, the variable has to be on the left side of the inequality. In equations, it doesn't matter. But for inequalities, the variable always has to be on the left side. The second rule is if you multiply or divide both sides of an inequality by negative, then the inequality reverses. For example, let's take negative 4b greater than 20. First question, is a variable on the left side? It is, so we're good. Second question, how do you get the b by itself? Well, the b is being multiplied by negative 4, and the inverse of multiplying is dividing, so we divide both sides by negative 4. Now on the left side, a negative 4 divided by negative 4 is 1, so we cross that out. Now when you divide both sides by a negative, the inequality reverses, so this is going to become less than. It's going to go from a greater than to a less than because I divided by negative, and that'll be negative 5. So we want the set of all numbers that are less than negative 5. Less than means we have an open circle on negative 5. Less than also means the numbers get smaller and smaller, which means they approach negative infinity. In interval notation, anytime numbers get smaller and smaller, on the left side we always have negative infinity, and on the right side they go up to 5, not including 5. So this is our interval notation. Okay, next. Before we even start the problem, the variable cannot be on the right side. Okay, so we got to keep that in mind at the very end, that the variable has to end up on the left side at the end. But right now, let's just solve for 3x. So I'm going to subtract 5 from each side. This gives us negative 15 is less than or equal to 3x. The x is being multiplied by 3, so the inverse of multiplying is dividing. So we divide by 3 we divide each side by 3, and this gives us negative 5. And now here's the thing, even though this answer is negative, we don't flip the sign because we divided by a positive. We did not divide both sides by negative, so the sign stays the same. It's going to remain an x. But the variable is on the right side. We need it to be on the left side. So imagine we take this whole inequality and you flip it in order to make the variable come on the left side. And when you do that, we're going to get x's, instead of a less than, we get greater than or equal to negative 5. And this will be your solution. So here we have negative 5. I'm going to put a closed circle. Greater than or equal to means numbers get bigger and bigger and they approach positive infinity. In an interval notation, my lowest value is negative 5 and the numbers are going towards infinity. So this is my interval notation. Last but not least, let's solve this one. So first step, just like an equation, we distribute. Negative 2 times 16, that is negative 32. Negative 2 times 3z, that is a negative 6z. And that's going to be greater than 48 plus 10z. Now at this point, you have a choice. You can either move all the variables to the left or the right. However, at the end, we want the variables to end up on the left side. So I'm going to make them go to the left side. So I'm going to subtract 10z from each side. Now when we do that, we get negative 32, these cross out, and that is greater than 48. Oh, I'm sorry, we don't cross those out. I misspoke. Negative 6 and negative 10 is going to be negative 16z, and that is greater than 48. The right side is where we cross things out. Now because the variables end up on the left, the numbers have to go to the right. So we're going to add 32 to each side. So on the left side, we have a negative 16z, and on the right side, we have positive 80. Okay, so I'm going to rewrite this over here. I have a negative 16z, and that is greater than positive 80. Now, how do I get the z by itself? Well, the z is being multiplied by negative 16, so we divide both sides by negative 16. And then this gives us z. Because I divided both sides by negative, the inequality flips from a greater than to a less than, and that'll be z less than negative 5. So we wanted the set of all numbers We have an open circle on negative 5. Less than means it gets smaller and smaller, and so they go towards negative infinity. So my interval notation is going to be negative infinity, comma, negative 5.